This film is about the firm of Robert Fletcher and Son Limited, the sole manufacturers of cigarette paper in Britain. The mill is located in the Pennine Hills on a 500-acre estate. A date stone reveals that there has been a mill on this site for at least 200 years. During the First World War, the mill produced bleached cotton for conversion into explosives. Robert Fletcher's commenced the manufacture of cigarette paper here in 1921. For the manufacture of cigarette paper, an abundant supply of very pure water, free from dissolved salts and colour, is required. Between 1958 and 1965, a large reservoir was constructed in the valley immediately behind the mill, and this supplies 20,000 cubic metres of water per day. Although this water is of the highest purity, all water used by the mill is chemically treated to remove the last traces of colour, and it is then filtered. The treated water from the reservoir is stored in the original mill pool. Historically, this pool was part of the system when the mill was powered by a water wheel. Nowadays, power comes from the grid, and the new machine is driven by a steam turbine. In 1975, a large new paper machine was installed at Greenfield, and much reconstruction of the mill took place. Output was effectively doubled by this installation. Here we can see the new machine house, which was constructed using the most modern methods. Cigarette paper is made from hemp and flax fibres because of their high strength and purity. These are imported from Europe and the Far East. All raw material receives close inspection before processing. After weighing, the raw material is reduced in length by passing it through a rotary chopper, and it is then blown through ducting to a digester. When the digester has received its weight charge of fibre, a metered amount of alkali is added. Each digester holds 4 tons of chopped fibrous raw material. These are spherical pressure vessels, each having a capacity of 20 cubic metres. There are 7 digesters. Steam is injected through the trunnions until a pressure of 450 kilopascals is reached. The digesters then rotate slowly to ensure uniform treatment of the material. A typical cooking cycle takes 12 hours. The time and pressure are carefully monitored and controlled. During the cook, approximately half the original fibre load goes into solution. Or, looking at it another way, the yield of cooked fibre is around 50%. At the end of the cook, the spent digester liquor is expelled. This is collected and metered to the domestic sewer. Subsequently, the liquor is mixed with domestic waste and treated on a payment basis at the local water pollution control works. The cooked fibre is discharged from the digester prior to further processing. Lignin is the main material removed in cooking. The digested fibre is conveyed to a press where excess residual liquor is removed prior to washing. This piece of equipment is called a potcher. Here the fibre is washed free from residual cook liquor, and some reduction in length takes place by the action of a 10-ton rotating barred roll working against a serrated stationary bed plate. The washed material from the potcher is then treated with a saturated solution of chlorine gas in water. The brown colour of the material is due to the presence of residual lignin. Lignin is attacked by chlorine and converted into chlorlignins, which are soluble in alkali. These are then washed out and the material treated with a little hypochlorite, resulting in a fully bleached pulp, or half stuff. These sequences show the bleached pulp being washed on a rotary vacuum filter. The pulp is then beaten, followed by refining. Both these processes expose new surfaces within the fibres. After dilution, the stock is spun tangentially, which removes contraries. This is the new paper machine showing the wet end, consisting of the wire of extremely fine mesh supported by foils to assist drainage, and the large watermarking roll, or dandy. This paper machine is computer controlled. The paper web is scanned continuously. The detector head measures substance by beta rays, moisture by infrared, and chalk filler by X-rays, and corrections are automatically made via a feedback loop. This machine is also equipped with a fault detector and continuous porosity measurement. The information from the scanner is displayed on a colour video screen from which hard copy can be obtained on demand. This sequence shows one of the smaller paper machines. The highly diluted stock, which contains only 0.5% solids, is mixed with pure calcium carbonate filler before passing onto the wire through a full-width slot with adjustable lips called the slice. Some water drains away by gravity, and further drainage is assisted by vacuum. The partly dewatered web passes under the watermarking or dandy roller, which impresses a characteristic pattern into the sheet. The wire then returns, and the paper sheet leaves the wire, assisted by a vacuum roll called the couche. The web of paper is then pressed and dried by being held against hot, rotating cylinders by felts. The cylinders gradually increase in temperature and the paper is progressively dried. This shows the continuous porosity measuring head with which all paper machines are equipped. A continuous record of porosity is obtained. The paper is reeled up, producing a jumbo roll. The jumbo roll has then to be slit into coils. This sequence shows the new Goebel slitter. This machine produces coils wound all in the same direction on a single shaft at a speed of 1,000 meters per minute. The slit coils are automatically offloaded from the machine onto a stripping table for separation. This type of slitter produces coils wound on two shafts. All coils produced are physically examined for freedom from faults. After inspection, the coils are packed in cartons or cases of various types. On the UK mainland, all deliveries are made in our own fleet of specially equipped vans. In our laboratories, the finished product is meticulously examined for its physical and chemical properties. Here the level of chemical additive, which controls the rate of burn, is being measured. This instrument is set up to perform automatic analysis of chemical additives, allowing large numbers of analyses to be carried out daily with minimum amount of labour. Tensile strength, elongation and energy to break are measured on this equipment. Close air permeability control is vital for present-day cigarette paper because of its influence upon the smoke yield of cigarettes. This is the Imperial Mark II air permeability instrument. Optical properties such as opacity and brightness are measured on this Zeiss El Rifo instrument. All analytical results are entered into the computer and summaries produced for record purposes and for onward transmission to customers. Fundamental research is carried out both at the mill and also in collaboration with Manchester University. Here, a programmed tube furnace is being used to examine the kinetics of cigarette paper combustion. The products of combustion of cigarette paper are collected and analysed using gas chromatographs. Research is continuous and ongoing, and problems such as reduction of carbon monoxide and side stream are currently being actively pursued.